Hello and welcome guys. In today's video, I'll be talking about and what effect does it play on an aircraft. Center of gravity is a point over which an aircraft would balance. The CG affects the stability. If you want to know more about that, check out my video. I'll put the link on the description box. An aircraft is safe to fly only if it lies within the limits of the CG. All the pitching, rolling and yaw moments happens about the CG point. Hi guys, in today's video I'll be talking about how to find the center of gravity of an aircraft. Now let's take the aircraft as a seesaw. Now the rectangle and the triangle which I have shown now is, I'll consider it as a wing. Now the datum line which I'm drawing now is given by the aircraft manufacturers. Now to the right of the datum line I'll take it as positive, and to the left I'll take it as negative. Now, the aircraft which I have drawn in this video is an example of a Cessna 172, where the engine will be on the front of the aircraft. So, since the engine is on the left side of the aircraft, we consider it as a negative side, and we take it as an example. If the engine has a weight of 100 pounds, that is 100 lbs, the moment is force in a distance, so we take it as moment is equal to the weight of the component into the arm length. Now we have the aircraft weight, as an example we took it as 100 pounds, and the distance from the aircraft engine to the datum line is, we take it for example as 10 inches for simplicity. Now since arm length is 10 inches, so it is 10 into 100, which is 1000 inches per pounds. That is the inches, and since the inch from the datum line is 10 inches and the weight of the engine is 100 pounds, the answer will become 1000 inches per pounds. Now we have the passengers as well as the pilots. Now considering the pilot situation, we have a pilot and a co-pilot on an aircraft. So we take it, for example, the pilots, the weight of one of the pilot is 60 pounds, so total will be, it will be 120 pounds. So the same will be the formula, that is arm length into the weight of the pilot. So we take it for simplicity, the arm length to be is 20 inches. So the moment will be equal to 20 inches into the weight of the pilot. We took it as 60 for one pilot, so 60 plus 60 is 120. So the total answer will be 2400 inches per lbs, inches per pounds. And now to find the center of gravity, the formula is, center of gravity is equal to the total moment by the weight of the aircraft. So the total moment when we calculate is 1000 plus 2400 by the total weight is 100 lbs for the engine, and 60 plus 60, that is 120 pounds for the pilot. So it becomes 100 plus 120, which is 220, which is 220 pounds. So when you calculate it, and you can get the answer as 15.45 inches from the datum line, and it is the duty of the pilot to check whether the answer lies within the permissible limit of the CG, and to check that it is done with the help of a graph. And this is a chart which is normally used by the pilots, and this is a graph between the aircraft weight and the aircraft moment. And what is inside the graph is, there are two categories which is mentioned, which is the utility category and the normal category. And the only difference is that in the utility category is mostly used by aircraft which are more acrobatic, which means that which are mostly jet fighter planes, or maybe acrobatic plane like the RC planes. And so for them the CG must lie within the utility category, and for the normal passenger planes the CG must lie within the normal category. And only if the CG lies within the permissible limits, the aircraft is safe to fly. Now I would like to talk about where the center of gravity is actually present on an aircraft. The center of gravity actually lies in front of the wing. Okay, and now the reason why the center of gravity lies on front of the wing is, now I'm going a short while, and now I'm going to draw as a center of lift. Now center of lift is actually a topic for another video. The center of gravity and the center of lift both have got different magnitude. The center of gravity has got a bigger magnitude when compared to the CL, so there is generally a tendency for the airplane to nose down. So to prevent that, we have got the horizontal stabilizers, which is the elevator. And this is one of the reasons why pilots are made to board the airplane before the passengers, because there are lots of procedures that a pilot have to follow before taking off from the ground. Okay, now I would like to talk about how a horizontal stabilizer or the elevator helps in bringing back the plane to a stable position. Now, taking this as an example, let's draw this a line, a horizontal line, which we'll take as the airplane. We have a center of gravity here, which is acting downwards, and we have a lift where the wings, the center of gravity is actually in front of the wing. So this is a wing, and we have a center of lift. The center of lift is another topic. It's a topic for another video. Now this is CG, the center of gravity. Now since the CG's magnitude is more than CL, there is a tendency for the plane to nose down. So to prevent that, we have a horizontal stabilizer, as I told before, and this helps in contributing to the stability of an aircraft. Now this I'll name as tail down force. So always keep in mind that CL will always be CG plus the tail down force. Now if the CG has got say 800 pounds and the tail down force is 400 pounds, so the total CL will be 1200 pounds. So when there's a change in the CG, there will obviously be a change in CL. So always CG is important for an aircraft, okay, because only on CG all the stabilities happen. We can pitch, we can roll, all those things happen on the CG. Now I would like to talk about a most commonly asked question about why some of the aircraft have the wing at the front and not at the middle or the back. Okay, let's take for the example the Cessna 172. The Cessna 172's wing is actually placed in the front and not at the middle or the back. Okay, now the reason is simple. Okay, let's take the case. Okay, I said that this is a wing. Okay, so this has got a larger distance. We call this a lever or an arm. Okay, it has got a larger distance, so therefore a smaller force is only required. Now to explain this more clearly, let's take the case example of a door handle. Okay, we don't place a door handle near to the hinge. Okay, we place it up far from the end so that it is easier, with less force we can pull the door. Okay, for this it is smaller distance and larger force is required. So for the pilots to apply the elevator more easily, the wings are placed at the front and not at the middle or the back. So doubts regarding any questions, do comment. Okay, thank you. I hope that all have got a firmly good idea how to find out the center of gravity of any airplane. So if you have any doubts, do comment on the comment section. Thank you.